Alright, determine if the following are even, odd, or neither. Okay, so we're going to be looking at even, odd. We're going to do a test for even, odd, or neither functions, right? We know that the test for even functions, and an even function just has a line of symmetry along the y-axis, right? So the test for even functions, f of negative x is equal to f of x. Okay, so you should know this, right? The test for odd functions, the test for odd functions is f of negative x is equal to negative f of x. Okay, so it'll satisfy that. And odd functions have a rotational line of symmetry along the origin, right? They have a rotational line of symmetry along the origin, and neither would not satisfy either or of these, right? So if f of negative x is not equal to f of x, or if f of negative x is not equal to negative f of x, then in this case this would be neither. Okay, so these are the three conditions that you kind of want to memorize, right? There are a few patterns, especially when we're looking at polynomial functions, right? For all polynomial functions, all even functions are even degree functions. Okay, so all even functions are even degree functions, but not all even degree functions are even functions. And what that means is that not all even degree functions, or any degree of a function which is an even number, not all of them will have a line of symmetry along the y-axis. So in that sense, you actually have to test this to see if it actually works, right? For polynomial functions, all odd functions will all have odd degrees. So all odd functions are odd degree functions, but not all odd degree functions are odd functions, right? An odd function means that they have a line of symmetry or rotational line of symmetry along the origin, right? So what that looks like is, say we are looking at the function y is equal to x cubed, and it looks something like this. Okay, so this would be like 1 and 1. Right, this is 0 and 0, and this is like -1 and -1, right? So this is -1 and -1. And really, if you drew a line of symmetry here that goes through the origin, and if you kept rotating it, right, this would basically cause these two ends to be mirror images of each other. Okay, so there's basically rotational lines of symmetry, and the point has to go through the origin, right? Now, an even degree function, on the other hand, if we wanted to draw one out really quickly, right? So I'm just gonna draw out a quadratic function really quickly, just drawing a scale, not drawing it to scale, sorry. Right, so let's say this is a quadratic function. It's y is equal to x squared, right? We can notice here that there is a line of symmetry that goes along the y-axis, okay? So in this case, f of negative x is equal to f of x. And in this case, let's switch colors here, f of negative x is equal to negative f of x. Okay, so that's basically what they are as a function. So let's do the test for each of these, right? So let's start with part A. Use a different color to just kind of separate all this. So let's take a look at part A. So we look at part A, we can see that this is an even degree function. It's a polynomial function. So if it's an even degree polynomial function, let's test to see if it's an even function. Right, so I'm going to do f of negative x. In this case, you get negative x squared minus 4, which is x squared minus 4, and this actually looks like its original function, f of x. So therefore, f of negative x is equal to f of x, and this is an even function. Okay, so that is part A. It's pretty straightforward. Part B, we can notice here that f of x is equal to 2x cubed plus x. So I'm going to do, because we know that the degree here is a 3, this is an odd degree function, and all odd functions are odd degree functions. Let's test to see if it's an odd degree function. So I'm going to first test f of negative x. If I test f of negative x, you get 2 times negative x cubed plus negative x, which is basically negative 2x cubed minus x, right? And then what I want to test to see is if negative f of x gives me the same result. So if I do negative f of x, I get negative 2x cubed plus x, and then if I expand this out, you get negative 2x cubed minus x. Okay, you can notice here that it's the same thing. So then you can say, therefore, f of negative x is equal to negative f of x, and this, in fact, is an odd function. So this is, in fact, an odd function. Okay, now I'm going to do part C. I'm just going to make some room here. I'm just going to erase this. But hopefully you guys can conceptualize what an odd and even function is now in terms of their graph, because really what it just refers to is a line of symmetry, right? So if we're taking a look at part C, this is not a polynomial function, right? So you have to do both of these tests. I'm going to first test f of negative x, which is equal to sine negative x plus negative x, sorry. And we know that this portion here is negative x, but sine of negative x is supposed to give us negative sine x, right? We know that sine negative theta is equal to negative sine theta, and tan of negative theta is equal to negative tan theta. Cosine of negative theta is equal to positive cos theta. And this is the reason for this is because negative theta implies, assuming that theta is an acute angle, negative theta implies a counterclockwise, a clockwise rotation from the initial arm. Okay, so this would be theta, and we know that our value is going to be in the fourth quadrant if theta is an acute angle, and we only know that cosine is positive in the first quadrant. So both sine and tan would be negative in the fourth quadrant. Okay, so we get negative sine x minus x, and I also want to test negative f of x, which is basically negative sine x plus x. I'm going to expand this guy out, and you get negative sine x minus x. So you can actually see that both of these are the same, so therefore f of negative x is equal to negative f of x, and this guy is in fact an odd function. Okay, so that kind of worked in this scenario.